If you're looking for budget V-mount batteries, then I'm going to do a bit of a deep dive in this video with these three specific V-mount batteries: the Neewer PS099EP, the K&F Concept KF-V99 Pro, and the Smallrig VB99 Pro. They're all from what I would consider budget or consumer brands, or maybe even prosumer brands, where the more budget but still very good quality brands being Neewer and K&F Concept, in my opinion, with Smallrig typically pulling ahead in terms of just a more well-known and usually more trusted brand, so a bit more of a professional or at least very high-end prosumer brand with the Smallrig. And there's nothing wrong with buying budget or prosumer equipment, so don't let anyone tell you that your budget isn't important, because budget gear at budget prices can work great if you know what job to use it for. But for this video, I'm going to go over the features of these three V-mount batteries and tell you my experience with them after about a month of use and which brand I would go with out of the options I have here. But my opinion on this and my recommendation comes down to how I intended to use these batteries in the first place, and how, honestly, none of them work exactly how I want to use them. But that's not entirely the fault of the batteries themselves, because I'm trying to use them in a way that ultimately may not be safe for these or any lithium-ion battery really, and that's because these batteries have smart protection systems which can limit some functions of the batteries if you want to use them to power your devices while keeping live power into the USB-C 1 power input ports of any of these batteries, or basically keeping them at full charge while charging them. And I'll get into that a bit later, but first let's go over the similarities and good features of all of these batteries. Now, all three of these batteries are really pretty great batteries. They all seem to hold up to their power specs just fine, they charge relatively fast, they're compact, and they all have tons of ports for powering multiple devices. However, keep in mind that all of the USB ports on these batteries can be a bit quirky. They all work, and I'll show you some examples of exactly how quirky they are here in a bit. And I will say that I bought all of these with my own money. Nobody sent these to me, and nobody is sponsoring this video. So I have here the Neewer PS099EP that I got for about $100 with tax. This one is the K&F Concept KF-V99 Pro, which came in at about $130 with tax. And this one is the Smallrig VB99 Pro, which is considerably more expensive than the other two, and I got it for about $190 with tax, but it often sells for around $200 to $250 before tax. And I got all three of these on Amazon.com, and I will leave some affiliate links in the description, and using those links certainly helps out my channel because I get a small commission from Amazon if you do use those links. Now, I was originally trying to stick to as low of a price point as I could while maintaining certain features on the battery, mainly the ability to have multiple USB ports, with one of those USB ports being a power delivery input port, and all three of these batteries do have and can be charged via USB-C power delivery. I bought the Neewer PS099EP first because it was the cheapest for seemingly the same features as the other two, but let's dig in a little more because all three of these have almost identical features. Other than obviously having a V-mount clip on the back so they can be mounted to any number of V-mount clamps or V-mount battery plates to power multiple devices, they are also all 99 watt-hour batteries so they can be carried on an airplane. They are all rated at 100 watts maximum on the input for charging and can be charged a couple of different ways. And they are all rated for 100 watts maximum output or load for all of the devices connected to any of its ports. So not 100 watts per port for everything you have connected to those ports. You have to take the wattage of each of the devices you want to power, add it all together, and that total has to be under 100 watts for any of these batteries to fully power all of those devices. They all have a bidirectional D-tap port which can be used for power output or as an input for charging. And the output voltage on the D-tap ports will vary a bit between about 14.5 volts to around 16.5 volts, and this can depend on how much charge the battery has on it, and generally the voltage will drop on any DC output as the battery gets used. They all have two USB-C ports, with the first port on each battery being bidirectional, so they can all be charged via USB-C power delivery on that first USB-C port. But since the USB-C 1 port is bidirectional, you can use it as an output port if you wanted to charge or power another device. And the K&F Concept and the Smallrig batteries both come with a USB-C power delivery cable that can support up to 240 watts on the cable itself, but the Neewer battery does not come with a cable, and none of the batteries come with a charger. You will have to supply your own USB power delivery charger yourself. For proper USB-C power delivery charging, you want to make sure that the charger you use and the cable are both capable of 100 watts power delivery if you want the batteries to charge at their advertised time of about 2 to 2.5 hours from 0 to 100%. You can use a USB charger that provides less than 100 watts, like say 65 watts from this Anker 735 brick, and the batteries will still charge. It will just take them longer to charge if you use a power brick that can't provide a full 100 watts like this Anker 747 can. They all have a single USB-A port, and that USB-A port is a QC or quick charge port, which means it can also negotiate the voltage between the port and your device and can provide anywhere from 5 volts up to 12 volts and a max of about 24 watts on that USB-A port on each battery. And keep in mind that all of the USB ports on these batteries are smart ports, or you'll see them called QC or quick charge ports, or if they're USB-C, they can do power delivery. And that means that when you plug in or unplug something into any of the USB ports on these batteries, the battery communicates with your device and has to negotiate what you just plugged in and what voltage that device needs. And each battery handles this process a little differently. And what that means is that the voltage that the battery is currently supplying to a particular USB port might change, and that USB port might actually stop working for a second when you plug in other things to one of the other ports. And that includes plugging in or unplugging power from or to the USB-C 1 port on some of these batteries. So if the USB ports do this renegotiation of voltage, or especially the momentary shut off of a port, then whatever you have plugged into one of the other USB ports may have its power disrupted. And this is basically the same for any smart USB port on any device, even most modern USB charging bricks, because they're too smart for their own good sometimes, and they all do this renegotiation of voltage when you plug in or unplug things from the other ports. They kind of have to do this so they don't exceed their maximum power output when all ports are in use. Now, this isn't a problem if the devices you're wanting to power from the USB ports on these batteries have their own built-in batteries, or if those other devices can be powered from a battery that you put in that device. Like if you want to charge your smartphone, this has a built-in battery, or your iPad or tablet, this has a built-in battery as well, or even this OBSBot PTZ camera, it has a built-in battery, or even feeding supplemental power to a mirrorless camera like the Sony FX30 on its USB-C port, or this Hollyland wireless video transmitter. Both of these devices have batteries. There's a battery in the camera, there's a battery on the back of this device, so these are under their own power right now. So if I provide power to them from one of these V-mount batteries via one of the USB ports, it would be supplemental power to all of these devices. And if that supplemental power is disrupted for a second or two, it won't matter, because all these devices will just fall back to using their onboard or inbuilt batteries. And although that may be obvious to some, let's just go ahead and demonstrate that real quick. We'll plug in a USB cable to the USB-A port on the Smallrig battery. We'll plug in our iPad here, and we can see right there that the iPad, of course, is getting power from the battery and is charging. But of course, if the power from the V-mount battery's USB port gets disrupted or disconnected, obviously the iPad will stay on as long as the iPad has a charge on its own battery. And of course, the same thing goes for cameras that have a battery in them. If I disconnect the USB-C power from my FX30, the camera just stays on and uses the battery in its battery compartment. But for devices that need constant power, like a Raspberry Pi computer or a mini travel router, each of which I wanted to power from the USB ports on these V-mount batteries, that hasn't worked out so well, because if the voltage gets disrupted or if the ports turn off for a second, then these devices will most likely turn off and have to reboot. And even if the ports don't completely turn off, this Raspberry Pi 4B needs a constant voltage to work properly. And even that momentary renegotiation of what just got plugged into all the other ports on any of these batteries can disrupt the devices that don't have their own internal power source. And I'm going to come back to the individual USB port performance on each battery in just a minute. But moving on, all three batteries also have a 12 volt DC output port, which can supply up to 3 amps or 36 watts max on that port. And those ports are 5.5 millimeter outer diameter with a 2.5 millimeter inner pin diameter. And that's actually how I power my Raspberry Pi, using a DC to USB power supply, which takes the 12 volt DC output from any 12 volt source and converts it down to a constant 5 volts on a USB-C connector. and that works well because these batteries don't have to renegotiate the voltage on their DC ports. All the DC ports on these batteries operate within a specific range for that port and should only drop a little bit within its range as you use the battery. And the Neewer and the Smallrig also have an additional 8-volt DC output port at 3 amps or 24 watts max, and those 8-volt DC ports have a 5.5mm outer diameter with a 2.1mm inner pin diameter, and you can use those 8-volt ports to power multiple things like your mirrorless camera with a dummy battery, because most mirrorless cameras need 8 volts in their battery compartments, but always be sure to check your voltages before plugging things in so you don't damage your equipment. But the KNF Concept only has that single 12-volt DC output port. It does not have an 8-volt DC port. And to note, the DTAP port and the DC ports are also not affected by any of that smart USB port renegotiation. The only thing that might get limited on the DTAP or DC ports is the amount of available amps or watts to each port if the overall power draw of all the devices connected to the battery exceeds 100 watts. Then all of these batteries will stop supplying some power from somewhere to stay under its maximum. And the KNF Concept actually has a little light on the back, a little flashlight. You hold down the power button for a second, the light turns on. It just gives you a little bit of a flashlight there. So if you're digging around in a dark bag, you can at least kind of maybe see the other items that you need to get out of that bag. Very handy, and you just hold the power button back down to turn that off and get to using the battery. All 3 batteries have screens on them that show you the current charge percentage, and if you have anything plugged in, it will also show you the in and out voltages of each port and the overall power draw in watts of each port as well. And they have a button on the top or the side which will turn the screen on to display all of the status information, and you can either press it again or double tap to get these different screens on each battery. But the Neewer is the only one that will show you the current usage of each port even when you don't have anything plugged into those ports. Just tap the button here on the top and then tap it again to switch between screens. The KNF Concept and the Smallrig require that you have something plugged into one of the USB ports or DTAP ports to show you the voltage and wattage use of each port. Otherwise, you only get the current charge percentage of the KNF Concept and Smallrig batteries. And if using the DTAP port only, the Neewer would show you the total wattage in use by that DTAP port. But the Smallrig would only show the total percentage of the battery itself. It does not seem to show you the total in-use wattage when only using the DTAP port. On the KNF Concept battery, if using only the DTAP port, you have to hold the side button down to view the in-use information on each port, which of course will turn on that little light on the back of the battery as well. But even then, and even though the KNF Concept shows a place at the top of the screen where the total in-use watts should be, it always read 0 watts in use. And again, this is when only using the DTAP port for output. So with the Smallrig and KNF Concept, you'll need to add up the wattage of all the attached devices before you power up to ensure you're not over that 100 watts maximum available output of those 2 batteries. And one more last little quirk about the screen readouts. When you're charging the batteries with either power into their DTAP ports or providing power to the BP ports from a V-mount plate that can provide power to the battery, the KNF Concept won't give any indication that it's charging other than the percentage going up. There's just no charge indicator. On the Neewer, the little battery indicator will flash to indicate that it is charging. On the Smallrig, you do get this little lightning bolt indicator here underneath the battery percentage. And again, these last little quirks are only when charging the battery via the DTAP port or the BP ports. And all of the screens will also turn off or sleep after a bit, especially if you don't have anything plugged in. And if the screens are off and none of the ports are in use, the DC and the DTAP ports I think will almost always provide power. If you just plug something in, you don't have to press the button or turn the battery on. The USB ports act a little bit differently on each one. Sometimes you do have to press the button to get the USB ports to turn on if they're not already currently in use or if the battery isn't supplying power to the DC or DTAP ports. But otherwise, you don't really have to turn the battery on with any sort of hard on or off power button. And all of the front screens on these batteries are a glossy finish, which isn't my favorite thing because they just show fingerprints on everything. I've been having to kind of shine them up on my shirt for this video so they don't show a lot of fingerprints, but that is what it is. Modern battery manufacturers just seem to like glossy screens, so I guess we're stuck with that for now. They all have rubber covers on all of their ports, including the D-tap ports. They all have contacts on the bottom so they can be used with a V-mount plate to expand to more ports or to provide charging to the battery via that V-mount plate, as long as that V-mount plate actually has a power input to be able to send power back to the battery. They're all fairly compact. The K&F Concept and the Smallrig are almost exactly the same size, while the Neewer is a bit taller and thicker overall, but only by a little bit. However, all of them are still larger than this SWIT 98 watt-hour battery. But overall, they seem to be well built. I even dropped the Neewer pretty hard on the concrete in the garage and only left a small dent on the top plastic edge here, and the battery still works just fine, so that's good news for the durability of the Neewer. However, with these glossy screens, I'm probably going to be much more careful with any of these, as I would think these screens might crack if I drop them, as opposed to something again like this SWIT battery that doesn't have any screens and seems to have a fairly durable outer shell. So all three of these batteries are really almost identical in terms of specs and number of ports, other than the K&F Concept not having an 8-volt DC port. And I've used these to provide supplemental USB power to my Sony cameras and primary power to this ATEM mini case that has an ATEM SDI Pro ISO, a monitor, Raspberry Pi, and travel router all at the same time from a single battery when I need to be more portable and use those setups in small spaces, or when power from a wall outlet may either be not available or just not available yet, which means I can use the battery to get set up ahead of time and then get power from the wall maybe later in the day. And for use as just a standalone battery, they've all performed just fine. I get good runtime out of them, and they charge fairly quickly with those 100 watt USB-C power delivery input ports. But real quick, I want to revisit the USB port quirkiness of each battery. Now, the Neewer's USB ports seem to need a minimum power draw from the device you want to plug into the USB port to even stay active. For example, these little USB lights need 5 volts, but only use about half an amp, which is about 2.5 watts. And if I plug it into the USB-A port on the Neewer battery, you can see the light comes on, it's getting power, but after about 5 or 6 seconds, this will shut off and eventually the screen will turn off. So I think the USB ports on the Neewer kind of need a minimum power draw to stay active. You can see there it turned off, and if we plug it into the USB-C port, we'll put a little adapter on it here, plug it into USB-C 2, we'll see if the light comes on. It does come on, but again, if we just give it about 5 or 6 seconds, this should turn off as well, again leading to the fact that the USB-C ports are probably going to need a minimum power draw to stay active. Right now it's staying on. We'll see if it turns off. Oh, yep, there it went. So you get a little longer in the USB-C ports. This doesn't seem to happen when I power something like my iPad or my smartphone or something that draws more power. So just be aware of that quirkiness on the Neewer battery. And this may have been why my little travel router kept rebooting when I was using the USB port to power my gl.inet travel router. I noticed during one show the router just seemed to keep rebooting, and I think that may have been why, because that travel router also does not pull a lot of power. However, the good news for the Neewer is that if you are using the USB ports to power other things or to charge other things, and then you plug in or unplug input power to the USB-C 1 port on the Neewer battery, if you plug in or unplug power, the other ports do not shut off. They may renegotiate voltage, but they don't seem to drop out completely, which is a bit of a problem with one of the other batteries coming up. And the same thing kind of happens with the K&F Concept battery. Plugging in this same small USB light that draws a little bit of power, it'll stay on for a bit. And sometimes if the battery had been sitting idle a while, I'd have to press the button on the side of the battery to make the USB ports active. And the USB ports, specifically USB port A and USB port C2, would generally stay active if you were using them to power or charge other devices when you plug input power into the C1 port. However, the bad news here is that if you have active power input into the battery and you're using those other USB ports to power other devices, and then you disconnect that power from the USB-C 1 port, the other 2 ports will drop out for a second or two. And you can see that here with this camera. Behind the camera, I have the video output from that camera being displayed, and when I disconnect power from the K&F Concept battery, the camera shuts off and has to reboot. Now, with the K&F Concept, I can plug power back into it and the other ports don't shut off. It's just for some reason removing the input power makes those 2 other USB ports kind of drop out for a second, so be aware of that. The Smallrig USB ports had some weirdness too, but I'd say fared a little bit better overall. If the battery had been sitting idle for a while with nothing else plugged into it and the screen had turned off and was kind of in this sleep mode, the light didn't come on sometimes until I pressed the button on the side. Also kind of like this battery needs a minimum power draw for the USB-A port to be active. But the USB-C ports on the Smallrig battery would always just provide power if I plugged in anything to them, even these same USB lights with a USB-A to USB-C adapter, and even if the battery had been sitting idle or sleeping for a while. But the Smallrig's USB-A port would also do this momentary dropout every few seconds if I had a low power device, again like this little USB light. We'll see it drop out right there for a second. So just some quirkiness with all the USB ports on these batteries. So I just make sure I'm not using the USB ports on these batteries to do anything except for charge other things that already have batteries, again, like my smartphone or my iPad or something that won't turn off if it loses its supplemental USB power that I'm providing from those batteries. And I guess lastly, on the Smallrig, it didn't seem to experience any USB port power dropouts if I wanted to provide power to the input of the battery, and the Smallrig also did not experience any power outages on the other ports if I pulled active power from its USB-C 1 port. So for me, the Smallrig kind of wins out on USB port performance, but not by much. Now, a lot of these USB issues can be solved by using a V-mount battery plate and then using the USB ports on that plate instead of the USB ports on the battery. But again, I'm just going to use them to charge other things. So that's the general overview. And as far as what I'd recommend at this point in the video, for me, the Smallrig wins out a bit because of its slightly better USB performance and smaller size over the Neewer. And the KNF Concept doesn't have that 8-volt port anyway, so that's one less option over the other two batteries. But honestly, the Neewer works great for the cheapest price, but this last section I'm about to talk about may sway your vote, and I was going to end the video here because it's getting a bit long, but I really want to cover this because there is one more very important scenario in how I wanted to ultimately use these or any V-mount batteries that none of these batteries performed very well in, and that's using them to power my downstream devices while keeping live power into the USB-C 1 port at all times, or basically keeping the battery full or mostly fully charged while in use. So I do this by having a power cable plugged into the wall, then a USB-C power delivery brick plugged into that cable with a 100 watt capable USB-C cable providing power input to the C1 port on the battery. And in theory, this should work fine as long as all of my downstream devices aren't using more than the 100 watts output load of any of these batteries. And doing it this way means I want to use the battery more as a battery backup rather than a primary power source for my devices. And that means the battery would still provide power to my downstream devices if the main AC power gets unplugged from the wall, like someone tripping over the cable. And I wanted to do it this way because with my work in live event production, I can't always be monitoring all of the equipment all the time. I sometimes need to get it set up and know that it has a backup power source in case something happens. And sure, there are other styles of battery backups like ones from CyberPower and APC, and I use those a lot too, but they're lead acid batteries mostly. They're big, they're heavy, they make audible beeps when they're not plugged into wall power. I doubt you can fly in a plane with them, and I wouldn't want to, so using V-mount batteries means I could stay compact if I needed to. The unfortunate part is that none of these batteries performed well in that scenario, and I was surprised because I've used this SWIT battery in a very similar manner with this blue shaped bag that has a power supply and V-mount plate. I have the SWIT battery connected to the V-mount plate in the bag. That plate has a power supply supplying power through it to the battery, and that power supply is plugged into the wall to charge or keep the battery charged. And I then use the DTAP output port on the battery itself to power an ATEM SDI Extreme ISO. And I've been using this setup for over a year for multiple live events, and this setup has never given me a problem. It's just never failed. Now granted, I'm usually only powering a single ATEM switcher in that setup, which is under 36 watts. And in my tests with these 3 V-mount batteries, I was powering an ATEM, a monitor, a Raspberry Pi, a travel router, a couple of converters, and charging some batteries. But all that still only adds up to around 80 to 85 watts and is still under the max load capacity of any of these batteries. So I tried using this setup on some live events with live power into the USB-C 1 port, And with the Neewer, sometimes it just wouldn't recognize that it had anything plugged into the input at all. Now this could have actually been because I was using an improper cable that was not capable of the full 100 watts, and after I switched to a proper power delivery cable, I have not seen the Neewer just not recognize input power. But luckily during those times it still kept outputting power and powered all of my devices, at least that never failed. And at other times the Neewer would get the proper 19 volts from my power delivery power supply, but would only pull about 2.18 amps, which is about 42 watts, while the battery was outputting or had a load of around 70 to 85 watts, which meant the Neewer battery would still drain, albeit it would drain more slowly than it would if it didn't have any power input at all. My assumption here is that the battery was probably getting hot and was protecting itself by limiting something, in this case limiting the input power while keeping the output power going so my equipment wouldn't turn off. The KNF Concept battery actually gave me an on-screen warning a couple of times when it was at full charge and while it was powering a lot of equipment, and at least once the KNF Concept battery completely shut off output power to all ports and my equipment completely shut off, and the battery again was still at full charge. And the warning looked like this, and the user manual just said that this icon means that the current charging port is detected as abnormal and there's no other information. So I can only assume the battery again was protecting itself, probably getting too hot and shutting down. But the fact that the KNF Concept shut off output power completely at least once means I don't really trust this one as much as the other two. However, with the KNF Concept battery, despite the warning on screen a couple of times, most of my other tests, it actually held or drew more input power from my USB-C power delivery brick. You can see here it's pulling 84 watts and it's still powering this entire A10 mini case and charging my iPad, and the battery is still holding that input percentage. So then I tried the Smallrig with this constant power input setup, and well, I got similar results where when it was near full charge and powering around 60 to 75 watts of equipment downstream, it would then for some reason only pull about 20 or 30 watts on the input. And this happened on another test where the battery had been in use for a bit and was at around 13% charge left, and I plugged in power delivery power to the C1 port while it was powering an ATEM Extreme and 2 video monitors, which added up to around, I think, 50 or 60 watts. But the Smallrig battery also only pulled about 31 watts during that test. So again, only pulling around 30 watts, the Smallrig battery slowly drained and my equipment shut off. And at least once on that test, I got this HT warning on the screen, which I believe is a high temperature warning. And this was in my hot garage, so the Smallrig also probably just getting too hot and protecting itself. Now, this isn't entirely the fault of the batteries. Had I read the specs beforehand, the Neewer manual states to protect the battery's lifespan, avoid simultaneous charging and discharging during the charging process, although it doesn't say you can't do this, just that you should avoid it to protect the battery's lifespan. The KNF Concept user manual said when simultaneously charging and discharging, yada yada yada, which means you should be able to do this as well. And the Smallrig says it can do this, charge and discharge at the same time. And again, my SWIT battery and that blue-shaped bag setup hasn't given me any problems. So I then tested my setup using a V-mount plate where the battery uses its BP ports on the bottom of the battery to basically run power into the plate, and I use the DTAP port output on the plate to power all my equipment. So all the output power from the battery is going out of the BP contacts on the batteries instead of any of the individual ports. And here I powered this ATEM mini case from the DTAP port on this Tilta plate, and this entire case and all of its equipment only uses around 65 to 85 watts. So I powered everything up and then fed power delivery into the USB-C 1 ports, again while using the output on the plate to feed power to everything else. And I got some better but varying results this way, with the Neewer sometimes pulling 19.3 volts and about 4.77 amps, which is about 92 watts, so that's good. But at least once the Neewer then only showed it was pulling 2.1 amps at 19 volts, which is only about 40 watts. And on my first test with the Smallrig, initially I did get some better results, with the Smallrig pulling about 90 to 92 watts while it was outputting or feeding about 75 to 85 watts to all of the devices. So that's a little bit of good news. However, remember that all of these and most modern V-mount batteries have smart protection systems that protect them from overvoltage, overcurrent, and overheating. And so it definitely seems that all of these results are affected by the temperature of the battery, and along with that goes the ambient temperature of the environment in which you want to use them, because of course, A room with an air conditioner will be colder, and that means the battery won't get as hot in some of those environments. And this proved to be true fairly quickly, where the Smallrig battery was holding good power input here in my fairly cold home office where it was about 75 degrees and about 50% humidity. But taking this setup immediately out to my garage, which was only about 80 degrees but much more humid at about 80% humidity, the Smallrig battery dropped to only pulling between 30 and 50 watts within about 5 or 10 minutes. And then, while still powered, I took the entire setup to my living room and put a small fan blowing on the battery to keep it cool. And then the Smallrig started drawing about 90 watts again on the input within a few minutes. Although it did have a little bit of a hard time charging, I think it was still trying to cool down, but at least it wasn't dropping in percentage overall. However, the input power draw on the Smallrig was never very consistent. In that last test, it did start to draw about 90 watts, even when it had a load of around 80 watts on the outputs, but then it dropped again to only drawing about 40 watts. And I did a lot more testing with all of the batteries, and here's what I can kind of say that I think is going on, and in which scenarios two of these batteries performed better. So remember that all these batteries can provide up to 100 watts to all connected devices. And if I loaded them down by powering equipment that added up to around 80 or 90 watts maybe, and then I tried to have live input power into the USB-C 1 ports, it was under those high load scenarios where all three batteries would only draw about 20 to 30 watts in most cases from the input port. So the batteries would still power everything that was connected to them, but they would start to drain in overall capacity, but they would drain more slowly than if they had no input power because they were pulling in some power from their USB-C 1 ports, just not enough to compensate for how much power they were outputting. For example, adding up the wattage of everything in this ATEM case, the ATEM, monitor, router, network switch, Raspberry Pi, Stream Deck, and the fans, that all adds up to only about 45 to 50 watts. And if I then also charge an additional NPF battery from one of the USB ports installed on the side of the case, we're now at over 80 watts sometimes. So all of these batteries can still power this entire case by themselves using the DTAP output port on the battery. 80 watts load is just fine. Again, they can provide up to 100 watts. But it's that 80 or so watt load that probably kept the batteries running hotter. And if I also wanted to charge them at the same time, that was obviously making the batteries work harder and probably producing even more heat. So the batteries started to limit their input power in those scenarios. But if I reduced the total wattage of the items I wanted to power, then they did better. So I unplugged unnecessary items like charging that extra NPF battery from the case, and therefore the total wattage draw of the case was now back at only around that 50 watt mark. So 50 watts load is half of any of these batteries' total available output load. And when I kept the output load at around or under half of the total capacity, then all of the batteries did better with that live input power. The Neewer would often draw 19 volts and about 2.18 amps, which is about 42 watts. So it had a 42 to 45, maybe 50 watt load that it was powering, while also pulling in about 45 watts, which means the Neewer would sometimes stay at the same percentage or very slowly drop some percentage points over a few hours. But if I reduce the load by having the fans on this case maybe run at their lowest speed, then sometimes the Neewer would actually charge and gain percentage. The KNF concept was the same, keeping the load that it was powering at about half of its capacity or around 45 to 50 watts. The KNF concept also held its charge. And the KNF concept actually performed the best in this scenario. I ran this entire ATEM case recording for 6 to 8 hours a day for a 2-day event, and the KNF concept held its charge at 100% the entire time while I had live input power into the USB-C 1 port. So that impressed me about the KNF concept battery. The Smallrig, however, was the worst performing battery in this live input power setup. The Smallrig, even though I kept the load at the same load that the KNF concept and the Neewer were powering that 45 to 50 watt ATEM case, the Smallrig would most often draw more power from the USB-C 1 port, and therefore the charge percentage would go up, so the battery was charging while having live input power. But almost every time, as soon as the Smallrig battery reached 100%, it would then just drop to only drawing about 20 or so watts, even though the output load hadn't changed. So the Smallrig would then just start dropping its percentage and eventually shut off because it was at 0% and dead. If I reseated the USB-C connector during those times, it would usually then kind of reset and draw more amps and therefore more watts and slowly start charging again. But when it reached 100%, again, it would drop to only pulling 20 or 30 watts. And this meant I really couldn't trust the Smallrig to run while inputting live power without keeping a constant eye on it. In addition, the Smallrig also gave me the most heat warnings and would stop outputting power altogether sometimes, even when I was just trying to charge my laptop, which it should be able to do. So to me, that proves that all these batteries are doing what they're supposed to and limiting the power to keep the internal heat of the battery down to keep it safe. And again, I can't fault them for that. So I guess here's what I'll say. If you can keep the batteries cool, and if you only load them down to powering about half of their maximum load, then they'll perform better with this constant input power charging while also discharging scenario. If keeping full-time power on the input is not as important to you and you just want to use them as standalone batteries, then any of them will do you just fine given some of their USB quirks. And maybe if you or I want different or better performance, especially in terms of constant input power, we might want to look at more professional V-mount batteries, as I would expect they might perform better with this live constant input power setup, but honestly, I'm not sure. If I ever get some higher end batteries, I'll try to let you know. But just remember, we don't have full control because the battery is in charge, pun intended, but unintentionally because I didn't notice I wrote that until after I was reading the script here. So that's my experience. I was surprised at the KNF Concept being the best performer given that random voltage warning, but at the moment it's the one I've been counting on more and more. So that's my 99 watt hours or 99 cents worth of V-mount battery mumbo jumbo. I will leave links to all these batteries below. I'm still using all of them and figure I will continue doing so because I now own all of them. So hit those like and subscribe buttons below and happy filming. All right, later.